On to the last section of chapter 10, which is percent composition and chemical formulas. As if we didn't have enough calculations, here are two more. So, we are going to talk about percent composition, and you see this in all sorts of things. Like if you're buying fabric or clothing, it will tell you the percent of cotton or whatever in that fabric. And so this is used a lot of places outside of chemistry. So how do we calculate percent composition? And I think this is fairly easy and you guys will catch right on. I'm not concerned about you understanding this at all, because when we talk about percent composition, percent should tell you how we're going to do this. We're going to take the part and divide it by the whole. So the relative amounts of the elements are expressed as a percent composition or percent by mass for each compound. So if we look at potassium chromate, if we know we can figure out the mass of potassium and we multiply that by 2 and plus the mass for chromium and then plus 4 times the mass of oxygen, and that would be our total, and then we could do each one individually. So I think you guys are going to catch right on. So the percents must total 100, so that makes sense. And if they are the same compound, the percent composition will be identical. But if they are not the same compound, the percent composition will be different. And so potassium chromate has a different percent composition than potassium dichromate does, because there is more chromium and more oxygen to the same amount of potassium. We do get a whole set of new percentages. So if you know the relative masses of each element in a compound, you can calculate the percent composition. And you know those masses by using the periodic table and multiplying the subscripts by the mass on the periodic table. So, percent by mass of any element would be the mass of the element divided by the mass of the compound and then times 100%. Pretty straightforward. So, when a 13.60 gram sample of a compound containing only magnesium and oxygen is decomposed, we get 5.40 grams of oxygen. So the rest must be magnesium, and I can figure out the mass of magnesium by subtracting 13.60 minus 5.40. So the subscripts you can also do percent composition by using the chemical formula. So you may either be given data like in this question, or you may be given just a formula and asked to calculate percent mass. And so again, you'd use the periodic table for that. So again, mass of one element in 1 mole of a compound divided by the molar mass will give us our percent of the compound, will give us a molar mass percentage, or the mass percent for that element. So propane, C3H8, is commonly used in gas grills. What is the percent composition for propane? So we're going to use the empirical formula or the molecular formula to calculate the mass of each element using the periodic table, just based on the formula of the compound. And we would multiply by any subscripts that we have in the formula, and then we're able to calculate the mass percent of each element. So propane has 2 elements. It has carbon and hydrogen. And since we have 3 carbons, we would multiply 3 times 12.01. And we have 8 hydrogens, so we would take 8 times 1.008. And then we would be able to figure out what the mass percentage is of each element. Here they've already calculated it out for you, and they figured out the mass percentage of propane and carbon is 81. The mass percent of carbon in propane is 81.8%. So that means if I had a 100 gram sample, it would be 81.8 grams carbon. We are going to work through the math of doing these calculations in class, so don't worry that I'm not showing you how to do these calculations. We will do them, I promise. So you can use percent composition to determine the mass of an element in a compound, and you can determine the empirical formula. And so empirical formulas is another formula that or calculation you're going to do. So this test is going to be very heavy on calculations. So calculate the mass of carbon and the mass of hydrogen in 82.0 grams of propane. So we know from previous slides, they already calculated out what the percentage of each is. And they want to know what the mass of carbon is and what the mass of hydrogen is in this compound. So we're going to go from grams of the compound into grams of carbon. We're going to go from grams of propane into grams of hydrogen. So be sure that you're labeling these and keeping track of all the little pieces. So the sum of the two masses has to equal 82 grams. And so I don't think I show you how to do this. We are going to do it in class, but you can calculate the percent composition if you know the mass of the compound and the masses of the elements contained in the compound, or if you know the chemical formula. The molar mass of a compound and the atomic weights of the elements are contained in that compound. So, empirical formula. The empirical formula of a compound gives the lowest whole number ratio of the atoms or moles of an element in a compound. The empirical formula may or may not be the same as the molecular formula. For example, the lowest whole number ratio of hydrogen to oxygen and hydrogen peroxide is 1:1. Thus, the empirical formula of hydrogen peroxide is HO. The molecular formula for hydrogen peroxide is H2O2, and this is twice the number of atoms in the empirical formula. However, they still are in a ratio of 1:1 or 2:2. So, carbon dioxide. The molecular formula and the empirical formula of carbon dioxide is the same. Seems pretty straightforward. Here we have two compounds that contain carbon and hydrogen, and they have the same empirical formula of C to H, 1:1. But they have different molecular formulas. One is ethene, C2H2. It's also called acetylene, and you can buy it at Home Depot or Lowe's, and it is what's found in Weller's Choices. And styrene, which is C8H8, which is still the same empirical formula, however, it's a very different chemical. It is what we see in styrofoam or polystyrene. So, key concept, and I'm going to stop right after this. There'll be 2 videos, and Easter eggs will be in the second one. Percent composition of a compound can be used to calculate the empirical formula of that compound. Percent composition tells you the ratio of masses of elements in a compound, and the ratio of masses can be changed to ratio of moles by using conversion factor based on molar mass. The mole ratio is then reduced to the lowest whole numbers to obtain the empirical formula of the compound. And again, like I told you, we're going to calculate that in class. I'm going to go ahead and pause here, and I'll be back with video 2. See you in a little bit.